So today we will start with the mathematical representation of the AM wave. So AM wave amplitude modulation. In the amplitude modulation, what is the mathematical representation and how it can be used further? We know that in the mathematical representation of the AM wave, there are three aspects. What are those three aspects? These three are the three component are there. So very first is the carrier component. So in the carrier component, you can see this part. So as this part here, this is what your carrier component. So this carrier component is what we see. The another part is this FC plus FM. That is what the second part. And the third part is this. So this is what this VC, that is what the center carrier. Then this is what FC plus FM, that is the upper sideband, and this is what the lower sideband. So these three components are there. This is what the general equation that initially we do. Now we have split up it into three parts. We will use the same equation for the analysis. 3-4 component we are discussing. For that, we will use this equation, what I am saying just now, that equation. Okay, so further, if you want to go, so what we will do next is this. So for that, I'll just remove this. Okay. So for this, what we can do that here mathematical representation and analysis of AM. So here what we can say, as I told, these three components are there, which is represented in the graph, whatever the graph of the mathematical representation. Three components are there. Modulation index, what is the modulation index is there. That we are going to see. If it is AM, then this is what the mathematical representation of the AM. Now the sidebands are there. This is upper sideband and this is lower sideband. Two sidebands are there. Then we will go for the frequency spectrum and the bandwidth. Now, for any communication, you require a bandwidth. What is the bandwidth of what the communication you are using? So here, the AM modulation is non-linear device. Okay. So in the non-linear device, this is FC plus FM is a upper band, FC minus FM is a lower band. So this is AM modulated wave consists of no frequency component of FM. How come? Because you can see there the modulated wave, in that only you will have the carrier component. So that's why we can see this. Now frequency spectrum of the amplitude modulated, what is this? DSBFC double sideband. This is double sideband full carrier. So this is what amplitude modulated double sideband full carrier wave. So this is what your equation. So in this, one component is this FC minus FM. This is central frequency and this is the upper sideband. So this way, this is what lower sideband spectrum and this is what the upper sideband spectrum. So lower and the upper sideband spectrums are shown here. Now further, if you want to go for the bandwidth calculation, how we can calculate a bandwidth? So previously here you can say that this is lower sideband spectrum, this is upper sideband. Difference between this lower and upper is what your bandwidth. That is a simple. So bandwidth of this double sideband full carrier is given by, this is upper sideband, that is FC plus FM. FC is what your carrier frequency. FM is what your modulating frequency. So carrier frequency plus modulating frequency, this is what your upper sideband, this one. And this is what your lower sideband. So you simply, if you will do, the FC will cancel it out and this will be 2 times of the FM. So 2 times FM is the maximum the signal of your modulating signal. Suppose I want to transmit my speech. So my speech frequency is how much? That is maximum, it is FM, max is 3.4 kilohertz. So I'll require 2 times of the 3.4 kilohertz bandwidth I'll get here. Okay. So this is what called the efficiency of transmission. This is what the bandwidth. Now we will go for the another parameter, or before that we will calculate some simple equation, what we discussed. Based on that, we'll do some numericals. So what is this? For a conventional AM modulator with a carrier frequency of FC equals to 100 kilohertz. So what it is given that the carrier frequency is 100 kilohertz. This is what given. And the maximum modulating frequency signal, that is FM max, is 5 kilohertz. These two frequencies are determined. Some components are asked here. That is what frequency limit for the upper and lower sideband. So what will be the frequency limit for upper and lower sideband? What will be the bandwidth? Then upper and lower sideband frequency produced when the modulating signal is changed to what? 3 kilohertz. What will happen? Now it is 5 kilohertz previously. Now in this C, it is given 3 kilohertz. Draw the output spectrum. So we will solve this one by one. So what is given here? Two frequencies are given. This is very simple. Whatever the spectrum we just have seen. So that spectrum we have to draw. That is the last one. So we'll see one by one. Upper and lower sideband frequencies. So simply, what is the formula for the AM amplitude modulated frequency band? The formula is simple. What? FC minus FM and FC plus FM. This is what lower sideband. FC minus FM. FC is what? Carrier frequency. How much it is? 100. 100 minus 5K. So it is 95K. Please check both has the same unit. Sometimes the different unit may be given. So this is what the lower frequency, that is 95K. Upper frequency is FC plus FM, 100 plus 5, that is 105K. Simple. Now bandwidth, anybody can give me the bandwidth? Lower frequencies and upper frequencies are given here. So anybody can give me the bandwidth? How much is the bandwidth? What you will do? Upper frequency minus lower frequency. So can anybody calculate bandwidth quickly? Very simple. How much it is? 105 minus 95. This is why 105? Because this is upper sideband. 95, this is lower sideband. 105 minus 95, this is 10K. So 10 kilohertz is what your bandwidth for this particular calculation, whatever the inputs are there. Now we will go somewhat different. Upper and lower sideband frequencies produced when the modulating signal is a single frequency. So if your modulating frequency is a single frequency of 3 kilohertz, then what will happen? Same formula, FC plus FM, FC minus FM. So same thing, FC minus FM. So FC is same 100 and FM is what? 3 kilohertz. So FC minus FM is 100 minus 3, that is 97 kilohertz. So that is simple. That is what 97 kilohertz is your lower sideband. And your upper sideband is what? FC plus FM. So 100 plus 3 kilohertz, so 103 kilohertz. Okay, so draw the spectrum. So what the spectrum, you know, MVC by 2. This is VC, MVC. M is what? Modulation index. And MVC by 2, MVC by FC plus FM, FC minus FM. And this is what? Your center frequency, FC. And you have to write the frequencies. That is FC here in the spectrum, you have to write the frequency. FC minus FM, that is 95. FC plus FM, 105. FC is 100. So this is what the basic frequency. You can change the frequency. That is what? Very simple calculation, simple things are there. Only you have to remember this formula, that is upper sideband and lower sideband. That's it. Is there any question? I don't think there is a question. That are the simple things. Anything else? Okay. So we'll move further. So this is what all of you, please take a screenshot of this numerical, because you have to do this. Tomorrow, next lecture, I'll just ask the solution for this particular problem. All are requested to take a screenshot. This is simple as the previous. And this is the homework for all of you. Simple, you have to calculate these many parameters. So calculate these parameters. Now we will go for the next. What is that? That is what the AM power distribution. So in the AM amplitude modulation, how you can calculate the power? Power calculation can be done in what way? So in the any electrical circuit, the power distribution is equal to the voltage RMS value divided by the resistance. This is what the general formula. So what we have the carrier waveform. So we can say VC by 2 is what voltage. So the formula for the power, that is the carrier power, we see the carrier voltage square divided by R. So what is the carrier voltage? That is the RMS value, that is VC by under root 2. So VC by under root 2 square divided by R. So what it will be? VC square, if you will simplify it, VC square by 2R. Okay, so VC square by 2R. So this is what your generalized formula. If your R is 1, then simply it is VC by 2. Okay, that what we have written, VC by 2. So this is the formula. This formula will require, and now we will calculate based on this formula, what will be the power for upper sideband, lower sideband, carrier frequency. This is what PC is what carrier power. So carrier power is calculated in terms of carrier power. We will calculate the upper sideband power, lower sideband power, and carrier power and the total power. Why we are doing this? Because for designing any transmitter or receiver, what he will require? He will require a power calculation. Based on this power, the distance traveled by the signal will be decided. So we'll not go for that, but at least we'll calculate the power calculation. So power. So for the AM power distribution, what is the base? Base is this formula. What is this formula? This is what we see carrier component. This is what upper sideband FC plus FN. This is what lower sideband. So this formula is the base for this AM power distribution. So upper and lower sideband power is given by. So upper PUSB, upper sideband, PLSB, lower sideband. So this is upper sideband power, this is lower sideband power, both the sideband having the equal power. So I have put equal sign, they are having the same power. So what is the power? So we know that as per this formula, upper sideband power. So upper sideband, which one is upper sideband? FC plus FM. So what is the voltage here? MVC by 2. So that is MVC by 2 square. That is what? V square. This total component is the voltage component. So MVC square by 2 divided by 2. We have taken the previous formula. That is V square by 2. So you just simplify this this M. So it becomes M square, VC square. 2 becomes 4. 4 into 2, it becomes 8. So what is M square VC square by 8? This is what the power content of each sideband. So upper sideband and lower sideband, how much is the power? It is in terms of PC. But can we convert in terms of PC? PC is what? Carrier power. So we know what is PC. Just now in the previous slide we have calculated. So this is what PC, that is VC by VC square by 2. So that is VC square by 2. It is what? Nothing but the PC. So VC square by 2, nothing but it is PC. So this is simplified. So M square by 4 into PC. So this is what your upper sideband and lower sideband power. This is what we have calculated. M modulation index is there. PC carrier power is there. M square by 4 into PC. Okay. Now, further, what we can do, we can calculate the total. What is total power? Total power, 3 components are there. From where you got the 3 components? From the equation. Why? Because here there are 3 components. That is the carrier component, upper sideband component, and lower sideband component. So based on this, we are calculating this. Total power is the carrier power, upper sideband power, and lower sideband power. Just now we have calculated the upper sideband and lower sideband power. PC also we have calculated previously. So PT equals to PC into M square 4. In terms of PC, I am trying to calculate. So M square 4 by PC, M square 4 by PC. This is what upper sideband. One is upper sideband power, one is lower sideband power. This is PC. So you can simplify this. So this is addition of this m square by 4. So it becomes m square by 2. M square by 2 into PC. So your total power becomes PC into 1 plus m square by 2. So what you can see, your total power is depend on the modulation index. If modulation index is higher, then your power will be higher. So this is what carrier power. Since the carrier power in modulated wave is the same as the unmodulated wave, obviously the power of the carrier is unaffected by the modulation process. If you will put this as the total power, so total power can be calculated by this equation. Now we will go further. Spectrum, previously what? The upper sideband, lower sideband in terms of voltage we put. Now in terms of power, separately there is a question in the exam, that is power spectrum. If you are saying power spectrum and if you are written here the voltage equations, then you will not get the marks. So power formulas, what we have calculated just now, that is required. Power spectrum of amplitude modulated double sideband full carrier wave is given here. So that is lower sideband, upper sideband, and this. So PC is equals to EC or VC, whatever you can say. So PC equals to EC square by 2R, and here lower sideband is M square PC by 2, and upper sideband is M square PC by, M square PC by 4, M square PC by 4. Both the bands are there. This formula need to be right. These three lines, this is the higher and this is the lower. Okay. So this three lines, if you will draw, you will get at least 2 marks. But if you will not write the formula, you will not get the mark. Upper sideband, lower sideband, and the center frequency FC. Now we will go the power spectrum we have calculated. Now we will go for the efficiency. Now this AM amplitude modulation has the low efficiency. Why this is so? That we will calculate. So for the efficiency, we have the general formula. Average power from the sidebands upon total power absorbed. So why average power from the sidebands? Because information content in the sideband. So that's why we have taken the average power from the sideband. And total power, how much power you are transmitting, that is the total power. From where this total power comes? Just now we have calculated total power. What is this? Upper sideband and lower sideband power. So lower sideband power plus upper sideband power divided by total power. This is what the formula for the efficiency. So what is upper sideband power and lower sideband power? Just now we have calculated. This is what M square PC. PC is what? Carrier power. M square PC by 4. M square PC by 4. One is upper sideband, another is the lower sideband power. PT equals to, in terms of PC equals to 1 plus M square by 2, total power. Now you just simplify it. So it becomes PC by 4, so M square PC by 2. Addition of this. And this is PC 1 plus M square by 2. So PC is common, so you can remove the PC. So here M square by 2, you can take it here. So it becomes inside 2 plus M square. This 2 will get cancelled. So M square, so the efficiency, whatever you pay efficiency, it becomes M square 2 plus M square. So your efficiency of your amplitude modulated wave simply depend on modulation index. So if your modulation index is how much, then what is your efficiency? That will just see. So here with 100% modulation index, the power in both the sideband equals to 1/2 of the carrier power. So if I'll put 1, then what it becomes? 1 square is 1, 2 plus 1 square is 1. So 1 by 2 plus 1, 3. 1 by 3 is how much percentage? 1 by 3, 33.33%. If I will have a modulation index of 1, then my transmission power efficiency is 33%. It is very poor because the envelope is there, 2 sidebands are there, and power content in the sidebands is the information. So that's why the efficiency of this particular amplitude modulation is less. Double sideband, full carrier, this efficiency is less. Now we can see the efficiency here. You can see what is the efficiency if modulation index is less, then what is the efficiency if it will increase, then what is the efficiency. Now here, if you will have the modulation index 2, 3, 4, 5, so you can see the efficiency is increasing. But can we afford to have a modulation index more than 1? Anybody can just comment. Can we get the modulation index more than 1? What is the disadvantage of the modulation index more than 1? Is there anything? If modulation index is more than 1, then what happened? Your overlap, the signal will overlap each other and you will lose the information. So we cannot, in amplitude modulation, we cannot afford to have the modulation index more than 1. So what you can say, at the max, we can have 1. So modulation, the power, the whatever the efficiency will be 33%. So simple example, we'll take it on this formula. So this type of examples are there. See, if you will have a presence of mind, you will get, you are able to solve. Okay, what is the numerical? For an AM double sideband full carrier wave with a peak unmodulated carrier voltage, VC equals to 10 volt, peak to peak, 10 volt peak. So VC equals to 10. Load resistance is given. So RL equals to 10 ohm. And a modulation index is 1. So these many parameters are given. Determine what to calculate power of the carrier, power of the carrier and upper and lower sideband. So 3 powers you have to calculate: carrier power, upper sideband power, lower sideband power. Formula is with you. Can calculate total sideband powers, upper sideband, lower sideband power. If you calculate, simply you have to add total power of the modulated wave. 3 you have calculated, simply add. Draw the power spectrum. Power spectrum just now you have drawn. So now we'll understand. So what are the given parameters? VC equals to 10 volt. Resistance is given. RL equals to 10 ohm and M equals to 1. So you have to use your PC equals to VC square by 2 RL. VC square by 2. If the resistance is not given, then you can assume resistance is 1. If it is given, then you have to consider the RL. So what will be the power? VC square by 2, 10 square upon 2 into 20, that is 20. So VC square by 2 RL, 10 square upon 2 into 10, so it is 20. 10 square is 100, 100 by 20 is 2 watt. So your carrier power is simply 5. Simple calculation, nothing great. Then you can calculate the upper sideband and lower sideband power. Upper sideband power is how much? Lower sideband power is how much? The calculations are there. So in the calculation, how much you are getting? The upper sideband, lower sideband power. Anybody can read this? Upper sideband, lower sideband power, how much you are getting? Quickly. 1.25. Okay. Now, what is the next? Total sideband power. So what? Upper sideband power is 1.25, lower sideband power is 1.25. So 1.25 plus 1.25, that is 2.5 watt is what? Total sideband power. Total power is addition of all the 3. PC, we have calculated 5 watt, upper sideband 1.25 watt, lower sideband 1.25 watt, add all these 3 components, so it becomes 7.5 watt is the total power transmitted by the amplitude modulated wave. And now we will draw the spectrum. Draw the spectrum, and in the drawing this spectrum, what we will do? So draw this spectrum, and in this spectrum, power formula for the power you have to calculate. So these are the formulas for the power. So that we have given there. So this is what the simple calculation, simple numerical, but it will be there in the exam. Now we will go for this last topic for the today. So this is modulation by the complex information signal. What it means? If you will have the multiple signals, that is, as this is FM1, FM2, FM3, three different frequencies is the example here given. If they are combined, then how the modulation index will be there. So this is somewhat complex. Previously, we have used the single waveform and having the modulation index simple. So by complex component, you will have this equation. So what this equation contain? So this force component is what? Carrier. So this component is there. Here, this long equation, this is one part, this is second, and this is third. So what is this? This is the carrier. So what is this second part? Lower and upper sideband FM1. So the formula is same. MVC by 2 cos 2 pi FC plus FM. Previously, we are using FC plus FM. Then here what we are using? FC plus FM1. Why? Because three components are there, three modulating frequencies are there. So we call this as FM1. And here what we call FC minus FM2, same formula. So this is what the one frequency component, very first FM1. So this is FC plus FM1, FC minus FM1. So lower and upper sideband of FM1. So एक frequency हो गया. Second frequency is this FC plus rest of the other formula is same. Only additional part is FC plus FM2. So here it is FM2. FC minus FM2. This is lower sideband, this is upper sideband for the frequency FM2. Similarly, for frequency FM3, lower sideband and upper sideband is there. So this equation becomes very long, but it is very simple to remember. Three components are there. So by this equation, what will be the spectrum? The spectrum is, this is center frequency FC, same thing. Then modulation index will change. This is M1 modulation index, M2 modulation index, M3. For the frequency FC plus FM1, upper sideband of the first frequency, FC plus FM2, upper sideband of the second frequency, FC plus FM3, upper sideband of the third frequency. Similarly, lower sideband of first frequency, lower sideband of second frequency, lower sideband of third frequency. Depending upon the VC is same, depending upon the modulation index, the amplitude can vary. As this one is the higher and this one is lower, this modulation index may be lower as compared to this, because VC is same for all. So this is what the frequency spectrum of what? Complex information signal. What we are considering? Three signal having the three different information signal having three different frequencies that we are considering. This is what given here. Now, how to calculate the total modulation index? That is the modulation index of first frequency plus second plus third plus fourth and so on, under root of this. So total modulation index is under root of M1 square plus M2 square plus, so simply root mean square. This is what the simple traditional formula you can calculate. Now, how the power calculation of the complex information signal can be done? The complex information signal power can be simply calculated by the same formula. Upper sideband PC MT by 4, total modulation index we are calculating, and lower sideband PC MT. So instead of M, we are saying MT, that is total modulation index, what we have calculated just now previous slide. And PT equals to total power equals to PC1 plus MT by 2. So this is what the simple thing. So we can have a simple numerical of this, and we will end after this numerical. So this is what for an AM double sideband full carrier transmitter with an unmodulated carrier power PC equals to 100 watt. That is modulated simply by three modulating signal with coefficient of modulation is M1 equals to 0.2, M2 equals to 0.4, M3 equals to 0.3. Determine what? Total coefficient of the modulation. So you have to take simply the under root square of this 3. Upper and lower sideband power can be calculated. Total transmitted power can be calculated. We'll see how can be calculated. What are the given parameter? PC equals to 100 watt, M1 equals to 0.2, M2 equals to 0.4, M3 equals to 0.3. So total coefficient of modulation is M total. Three components are there. So that's why I taken M1 square plus M2 square plus M3 square under root of all. So 0.2 square plus 0.4 square plus 0.3 square. How much it is? So it is MT equals to 0.5385. So if you will calculate this. So this is what very simple. Upper and lower sideband power. So total upper sideband and lower sideband total power. So PC MT by 4. PC is given how much? 100 watt. MT total. Now you have calculated 0.5385 square divided by 4. So how much it comes? It comes 7.25 watt. That is upper sideband, lower sideband, and this power. So this upper and lower sideband power is 7.25. Total transmitted power can be by this formula or by adding all this formula. So it is simply 114.5 because 100 is this, 7.5 upper sideband, 7.25 lower sideband. So 7.25, 7.25, 14.5 plus 100 this, or you can use this formula. Both the formulas are there. You can use anything. So this is what the given here. So this we'll see in the next lecture. Anything else?